So 2.4 is on simplifying radicals. And simplifying a radical just means that we're going to make sure that the value underneath the radical, that all the grouping that I can possibly do based off the index or the root, those groups are taken out of the radical. So I'm just going to say appropriate groups. Let's see, appropriate root groups are removed from the radical. And that will make more sense in just a minute. All right. So when I look at example 1, remember we talked about how if there's not a number on the shelf, there's really a 2. Okay, so that's really like we're looking for groups of 2. And so what we're going to do is we're going to take that 96 and we're going to try to remember what's something that goes into it. Now, if we know our times tables and we're like, hey, that's going to be easy for us and we can start with a basic times table, great. If we can't, then we know that it's an even, so we at least know 2 goes into it. Or we can see that 3 would go into it because 3 goes into 9 and 6. It doesn't matter where you start because eventually what you're going to do is you're going to break it down to all the prime factors. And so you can start wherever you want. If I start with 3, then I know 96 divided by 3 is going to give us 32. 3 is prime, so it's going to stay where it is. And we're going to divide it by 32. Now, another way that we can look at this is like we can just divide it out. So if I look at 96, I'm going to divide by 3. And so we can say, well, if I divide by 3 or 2, whatever you're going to do, let's say we're going to divide it by, like we did with 3. So if we divide by 3, we're going to get 32. And then if I divide 32 by 2, or you can divide by 4, but let's just go prime factors. So if I divide by 2, I'm going to get 16. If I divide by 2, I'm going to get 8. If I divide by 2, I'm going to get 4. And if I divide by 2, I'm going to get 2. And so I can't go any further. And so now I'm looking for groups. And remember we said if there is a 2 here, we're looking for groups of 2. So I need 2 of a kind. So I have 2 2s here and I have 2 2s here. All right. And so I'm left with the 3 and the 2 left over. If I look at the x to the 4th, it means I've got 4 x's here. And again, I'm looking for groups of 2. So I've got 2 x's and 2 x's. Anything that has a pair can leave or goes out of the radical. So I've got a pair of 2's here. So I'm going to write it down on the outside. I have a pair of 2's here. I'm going to write it down on the outside. I have a pair of x's. I'm going to write it down on the outside. And a pair of x's. I'm going to write it down on the outside. And then what's left underneath the radical is the 3 here and the 2 on the bottom. Okay. And so we're just going to multiply those together. So 2 times 2 is 4. X times x, x squared. And then underneath the radical, 3 times 2 is 6. And so this would be what I'm left with as my final answer. And so it's just simplified down. If I look at example 2, we're looking at the same idea. Again, this one, it starts with a 3. So that means I need 3 of a kind in order to pull out. The other thing with example 2 is you're noticing that the 2x is already on the outside. Again, you do that however you want to. I'm going to look at the variables first and notice that it's x, x, x. Okay, so there's 7 x's. 1, 2, 3, 4, 5, 6, 7. And then when I look at the 162, I'm not sure exactly what goes into it, so I'm just going to start with 2. So if I divide this by 2, take a 2 out, I'm going to go 16 divided by 2 is going to give me, I'm just going to write that a little bit different. So if I take the 2 out, 162 divided by 2 is going to give us, let's see, 81. And then 2 doesn't go into 81, but we know 3 does. So 3 into 81, or maybe you know that 9 does. It doesn't matter. I like to do it a little bit different. I showed you the box way. I'm going to show you the way I like to do it. So this is 2 and this is 81, and 2 is prime. So I can't go any further. Then 81 is 9 times 9. And because I broke it down further, I usually just cross it out. And then 9 breaks down to be 3 times 3, cross it out. 9 breaks down to be 3 times 3, cross it out. So just another method. These are all prime numbers. They don't go down any further. And so I'm done at that point. And now when I look at it again, I'm looking for a group of 3. So I have 3 3s here that can leave or go out of the radical to join the 2x, the 2 and the x that are already out there. So notice that this 2x is coming straight down, like it's still there. And then what I do is I'm looking to see what I have 3 of a kind. So I have 3 2s, so I'm going to bring a 3 out. I have 3 x's and 3 x's. So when I look at that, I've got 3 x's here, comes out. I have 3 x's here, comes out. And then that's the only 3 of kinds that I have. And so what happens is then I have the part that's left over. So the part that's left over is a cubed root. And then I've got a 2 left over, a 3 left over, and an x left over. Okay, so notice where those are. X left over, 2 left over, and a 3 left over. And then I simplify what's on the outside. So 2 times 3 is 6. X times x times x, or 1 plus 1 plus 1 makes 3. And then it's a cubed root. Underneath, 2 times 3 is 6, and the x gets tagged on. So this would be my answer. Okay, and again, I grouped it in 3s because there was 3 of a kind. Looking at example 3, same idea. The 3 and the y are already on the outside, so I want to break down the 45, and I'm just going to do it going down like in a tree. 45 is 5 times 9. 5 is prime. 9 will break down more. Because it breaks down more, I'm going to cross it off. When I look at my variables, I have 3 x's and I have 4 y's. All right, and so now, again, 5 is prime, 3 is prime, 3 is prime. They don't go any further. When I look at the value, the index, the root, whatever you want to call this, the number that sits on the shelf, there's not anything there, so we remember there's a 2, which means I need 2 of a kind. This is coming straight down, so this is already 3 times y. I have a group of 3s. I'm going to write it down. I have a group of x's. I'm going to write it down. I have a group of y's. I'm going to write it down. And another group of y's. I'm going to write it down. And then what's left over underneath the square root is a 5, which is here, and an x, which is here. Okay, there's nothing else left over. And now we just simplify the outside. So 3 times 3 is 9. Again, order doesn't really matter. I've got 3 y's, so y to the third, and we have x. Personally, I usually write the x first just because it comes first in the alphabet, and then 5 times x is just 5x. And so this would be my answer. And this is how we simplify a radical. So we're going to stop here, and then the next video we'll talk about the second part of this.